All right. Hey, guys. Welcome back. This week, we're going to start with inequalities. Big, scary word, nothing to be worried about. Inequalities are going to be on the test. They're going to be part of equations. And really, all that changes is the sign. There is no longer an equal sign. Instead, it is an inequality sign. Y'all should have gone over this last year in 6th grade. So hopefully, none of this is too new. So what are inequality signs? Well, an equation uses an equal sign to show both sides are equal, an equal sign. But an inequality shows that both sides are unequal. They're not equal. One can be more or less than the other. So we have 4 different inequality symbols. We have greater than, which looks like this. We have greater than or equal to, which is the greater than symbol, and a line underneath. Anytime you see that line underneath, it also means or equal to. Less than, which is the opposite of the greater than, and then less than or equal to. We read these signs like we read words. On words like the word greater, we read it from left to right. We do the same thing with these signs. So if you see the open mouth first, the big side, that is greater than. If you see the small end first, that is less than. So let's look at some of these examples. All we're going to do here is basically pick the sign that goes. So we have a 4 and a 9. Which one is bigger? These signs, the mouth always eats the bigger side. Well, 9 is bigger, so the mouth will eat the bigger number. And we read this like 4, and then we see the smaller end first. 4 is less than 9. This second example, 0.5 and 0.45. Well, 0.5 is bigger, so the mouth of the sign is going to be eating the 0.5 first. So we read this as 0.5 is greater, see the mouth first, than 0.45. Or if we wanted to flip it, 0.45, this is the same thing. These two sayings are the same. 0.5 is greater than 0.45, or 0.45 is less than 0.5. That's like saying 10 is greater than 5, or 5 is less than 10. Same thing, but the words aren't moved around. -3 and -2, which one is greater? Remember, these are negatives, so the number that's closer to 0 is bigger. So we're going to have our mouth eat the -2. -3 is less than -2. Or if we want to write it backwards or flip it, -2 is greater than -3. It means the same thing. My numbers are just flipped. Okay, let's move on. Some examples. Kind of get into solving here a little bit. Here, we're going to see if these are true or false. Number 1 says 12 is less than f. We have a variable here. And it also tells us that f equals 3. So we're going to take this 3 and we're going to plug it in. So 12 is less than, instead of f, we're going to plug what f is. 12 is less than 3. Is that a true statement? 12 is less than 3? No, it is not. It is false. You'll have to do this on one of the IXLs later. Number 3 says 8. I'm sorry, not number 3. That's number 2 first. Number 2 says b plus 7. And then here, look at this line. This line means equal to. So b plus 7 is the big mouth greater than or equal to 12. And it says b is 6. So we're going to take 6 and plug it in for that variable b. 6 plus 7 is greater than or equal to 12. Let's see if this is true or false. 6 plus 7 is 13. Is 13 greater than or equal to 12? Yes, it is. It is true. Now, number 3. 8 is less than or equal to x minus 2. So now we're going to solve, and plug in this number for x, says x equals 10. 8 is less than or equal to 10 minus 2. So 10 minus 2 is 8. Bring everything else down. Is 8 less than or equal to 8? So here we see, is 8 less than 8? No, it is not. 8 and 8 are the same. But this sign is 8 less than, because we see the smaller side first, less than or equal to 8? And in that case, yes, it is. It is equal to 8. So it is true. And I did forget to mention this, but everything that's going on in this video, hopefully y'all are writing this down in your notes and keeping a journal of all the notes for the year. Number 4 says 6 is greater than negative 2x minus 2. This one's a little bit more difficult. If you think you can solve it on your own, you can pause and try and do that. 6 is greater than negative 2x minus 2. But instead of x, we're going to write what x equals. It says x equals negative 4. So negative 2 times negative 4, because there's no symbol in between the two, minus 2. So now we're going to solve this. Negative 2 times negative 4, our integer rules still apply here. 2 times 4 is 8, and a negative times a negative is a positive. So now here we have, bring down the 6 one more time. 8 minus 2 is 6. 6 is greater than 6. Is 6 greater than 6? No, it is not, so it is false. If it said 6 is greater than or equal to 6, then it would be true, but it does not. So this one is false. Okay, so now that we've discovered what inequalities are and how to see if they're true or false and what the signs mean, we can also graph number lines. Graphing them, it gets a little bit more detailed, but it's not too hard. So we have 4 different signs, and each one can be graphed a different way. So things that are included, and this will make more sense here in a second, but we have greater or less than or equal to, or greater than or equal to. If it's included, both of these are represented by a shaded circle. Not included would be less than or greater than. Those are going to be represented by an open circle. So here we have the example. X is less than or equal to 5. So let's think about this. X is less than or equal to 5. Can X be 5? If it's less than or equal to. Well, or equal to means yes, X can be 5. So what you're going to do is you're going to look at this number, whatever X is less than or equal to, and you're going to find it on the number line. 5 goes in between 4 and 6. So I'm going to put a circle on that number 5. And I'm going to shade everything X can be. So if X can be less than or equal to 5, can it be 5? Yes, it can be 5. So I'm going to shade this circle because X can be 5. I'm going to shade everything X can be. And here it even says to the left, these signs are represented by a shaded circle. I'm going to shade everything else that X can be too. X can be any number less than or equal to 5. So can it be 4? Yes. 3, 2, 1, 0, negative 1, negative 2, and so on. So this, we are going to shade the number line, the direction of all the numbers that X can be. We do not shade 6 because X cannot be 6. If X is less than or equal to 5, 6 is not less than or equal to 5. So here we've got some examples. If you want to pause the video on any one of these and see if you can solve it on your own, you're more than welcome to. Otherwise, I'm just going to go through and solve each one of these. Number 1 says K is greater than 11. K is greater than 11. So I'm going to find 11. I'm going to put a circle on it. And I need to decide, is this circle shaded or unshaded? Well, if I go back to the previous page, these symbols are represented by an unshaded circle. So I'm going to leave 11 unshaded. Also, it says K is greater than 11. So can K be 11? No, K cannot be 11. So therefore, it is not shaded. We only shade things K can be. K is greater than 11. So I'm going to shade everything that's greater than 11. And that's how we graph number 1. Number 2, 12 is greater than or equal to f. So I'm going to find 12 on the number line, and I'm going to circle 12. 12 is greater than or equal to f. Can 12 be f? Can f be 12? Well, if it's greater than or equal to, yes. So therefore, it is a shaded circle. And if 12 is greater than or equal to f, well, then that means f has to be what? Well, less. It might be easier if we flip this inequality. So f, I see that the small side is pointed to f, so I'm going to keep the small side pointed to f. And this means the same thing. F is less than or equal to 12. So I'm going to shade everything that is less than. Everything that f can be is shaded, including the 12. Number 3, c is less than 25. I will find 25 and put a circle on 25. Do not put the circle above it. Make sure we put it on the number line. It's a mistake a lot of people make. So c is less than 25. Can c be 25? No. So therefore it is unshaded. And we shade everything that c can be. C can be 24, 23, 22, 21, and so on and so on and so on. So everything else gets shaded. And number 4, x is less than or equal to 4.5. I'm going to find 4.5 on the number line. That is in between 4 and 5. And I'm going to put a circle on 4.5. So we're going to ask ourselves, can x be 4.5? Well, less than or equal to? Yes, it can. So I will shade 4.5. And x is less than or equal to. So I will shade everything that is less than. Less than. Real quick, just if we wanted to write these inequalities, if we wanted to flip them, make sure that the signs are eating the same numbers. So if I want to put 25 on this side and c on the other, my sign still has to eat 25. If I were to flip this one, my sign still has to eat 4.5. These are all equivalent inequalities. So keep that in mind if you ever come across one like number 2 and you want to flip the inequality to make it look easier for you. Okay, we're going to practice now with a word problem or an expression. So I'm going to read number 1, and then we're going to take that information. We're going to write our own inequality and then also graph it. If you want to try it on your own, you can pause it. Otherwise, keep working with me. The McDonald family spends no more than $150 each week for groceries. So this is going to be a simple inequality. We don't know how many weeks. So X is going to represent what they can spend. So if I put my X here, well, this is the only number I've got. So X can be greater than, less than, greater than or equal to, or less than or equal to $150 each week. So if I say you can't spend more than $150, could you spend $150? Yes, you could. Could you spend $151? If I said don't spend any more than $150? No. Could you spend $1, $2, or $3 or $149? Yes. So X needs to be anything that is less than or equal to 150. So I'm just going to put it on my number line. I'm going to put 150 in the middle, make it easy. Put 155. Just go by 5s. 145. You can go by 1s. You can go by 5s. You can go by whatever you want to on this number line. I'm going to put a circle on 150. Can X be 150? Can you spend 150? Yes, you can. Just don't spend more. You can spend anything less than or equal to 150. Number 2, Jared earns at least $10 per hour while mowing lawns. At least is our key word here. So what Jared earns and $10, what can X be? Can X be bigger, smaller, the same? Well, if I say you are going to make at least $10, would you expect to make $9? I hope not. Jared earns at least $10, which means X can be greater than or equal to. You can earn 10 or more dollars. So I'm going to make my number line. Let's put a 10 in the middle, 11, 12, 9, 8, and I put my circle on 10. So if x can be greater than or equal to, it means it can be 10. So I'm going to shade 10, and x can be anything bigger than 10. So I'm shading everything that's bigger than 10. I think that's it. That is. If you guys have any questions, please shoot us an email. 10 tutorials. Please work on the IXLs. Those are a great practice, and they can really help you. Have a good day, and I guess until next time.